When current enters through a resistor, is it always a voltage drop? Which node or terminal of the resistor should be positive and which one should be negative? If you have a voltage source, is it always guaranteed that it will result in a voltage gain? Or can you also have a voltage drop with a voltage source? Is nodal analysis the best way to solve any circuit? Do you always have to get your current assumptions correct in the first go? Or can certain adjustments be made after you complete your circuit analysis? I answered these and many other questions in this session, which was conducted with my students who are preparing for the FE Electrical and Computer exam. So without further ado, let us dive into the content. But the real action is over here. I have a voltage source. If the current leaves the positive terminal, then only I'm going to record it as a voltage gain. If the current enters a positive terminal, it will be a voltage drop. That's the only thing I want you to take away from KVL. It's as simple as that. And the real application of KVL is in mesh analysis. Let's look at KCL. KCL is also very simple, extremely simple mathematically, that the sum of all the currents that are entering a node should be equal to the sum of all the currents that are leaving the node. What's the big deal? Very intuitive, right? So if you have a junction, right, and the sum of all the cars that are entering here should be equal to sum of all the cars that are leaving. It's as simple as that. But what is the issue? Here's the issue with KCL. Students are not able, when they make mistake, they are not able to translate the directions of current and their assumptions into proper equations that are consistent with those assumptions. That's the big issue with KCL. And another thing you must remember is that there is no right or wrong assumption. Obviously, there is a right or wrong answer. There's only one correct answer as far as the magnitude and direction of the current is concerned. But if your assumptions are off, KCL will automatically take care of it by giving you a negative current. So when you're going to circuit analysis, don't freeze yourself. Don't get paralyzed that let me actually just somehow figure out what is the correct answer or the correct direction for the current. Because if I don't select the correct direction, I'm not going to be able to solve it. That's wrong. That's not the case. If you know what you're doing, it will all work out. So let's dive into some practice problems and it will start making more sense. This is a problem from one of my examples that I do in my on-demand course, and we'll quickly work through this. I'm asking you to do a KCL to calculate the current I0 that is passing through this 2K resistor. Make sense? So how will we go about it? How will we go about it? There are a few steps that are very important to take. Number one is to mark the nodes at which you are going to write KCL. So which points in this circuit will qualify as a node? Is this a node? Unique node? Is this a node? Not really, because there's no circuit element between these two guys. So these 2 points on the right are basically the same. This and this point are basically the same. The reason that this point are not the same is because there's a 2K resistor. The reason between why this point and this point are not the same is because there's a 3K resistor. If there's a circuit element, whether there's a resistor, where there's a current source or voltage source, it basically creates a new node. So what we need to do is we need to write KCL at these 2 points. The other important step is that you have to classify a reference point through a virtual ground. Now and you can pick any point for that, but as you can see that this will serve as a good reference point because this is a point where most of the branches, all the branches are actually meeting. So we can call this a 0 volt reference. Make sense? And then I'm going to start writing KCL at this point and a KCL at this point, and you will see that it will work out just fine. All right. There is no one correct assumption for current direction. In terms of current direction, if you want to understand what should be the correct current direction, you can start off at a right footing by recognizing that the 9 volt source is probably pumping current into the circuit. This is the only voltage source over here, only power source. So if you ask me, Wasim, what should I assume for the direction of current going through this 3K resistor? I'll say it will be from left to right, because on the left side you have a voltage source. Now, if this is the only current source, think about it like a water pump that is pumping current through the 3K resistor, right? And think about the 0 volt as a ground reference as a flow, right? So under the action of gravity, current will probably flow like this, right? It will all come back to the 0 volt reference. Does it make sense? Now, this is not the only current direction that you can assume. I invite you to go through another attempt of this circuit by reversing all of these directions. And I can guarantee you that your final answer, when adjusted for direction, will be exactly the same as mine. But intuitively, right, this makes a lot of sense. Agreed? Any questions, any concerns about this? So these are the directions that I'm assuming, that there is only one power source pumping current, and then from that point onwards, the current is branching out and returning back to the negative terminal of the power source or to the 0 volt reference over here, making a complete loop. All right. So this is how we're going to write these equations. So if I look at, if I call this as B, and if I call this as A, so VA and VB, right? So if I want to write an equation for I naught, knowing that this is 0 volt ground reference, can you guys see that the delta VB minus 0 volt, so delta V divided by the 2K resistor is the correct equation for I naught? Any issues with this? Current will flow from a high potential to a low potential. That's what delta V is. V high minus V low divided by resistor, correct? So the direction that we've assumed is this direction, going down, right? So this becomes VB minus V0, 0 volt divided by 2K. Any issues with this? That is one of the equations, unique equations that I can write. Now, when I'm writing the nodal equation, the KCL, at point A, I have assumed that the current is entering through here and the current is actually leaving like this. And this is the 0 volt. So for the current that is entering this guy, all right, I am assuming that 9 volt is a higher voltage. So 9 volt minus whatever this unknown voltage is at VA divided by 3K. So this is the sum of current I in entering. And it should be equal, from the standpoint of this node, should be equal to the total of current that is leaving. So the two currents that are leaving are VA minus 0 divided by 6. That's basically the current through this branch. And then the other one is VA minus VB, VA minus VB divided by 2K. So that's a current through this branch. Clear? That's my second equation. Now, this is where students make mistake. When they go about writing the nodal equation for the second node, what they end up doing a lot of times is that they reverse the direction. They're like, okay, you know what? Now I feel like the direction of this current towards left and this to the top as well. Please don't do this. That's where your assumptions have to make sense with the equations. Once you have assumed the directions, they're frozen for this circuit analysis. You cannot just go back and forth. So this is the direction of current going from VA to VB. When I'm writing the nodal equation, I have to freeze this. The equations that I'm going to write will have to show these current directions. So from the standpoint of VB, the current that is coming in is this guy, which is VA minus VB divided by 2K. The current that is leaving, one of them is this one, which is VB minus 0 volt divided by 2K. Remember, we have a ground over here. And then the other one is this guy, VB minus 0 divided by 2K. All right. If you look at the set of equations that I have now and the number of unknowns that I have, how many equations do I have? 3 equations. 1, 2, and 3. 3 unique equations. How many unknowns do I have? How many variables have I used? VA is clearly one variable. VB is another variable. And I naught is another variable. So if I have 3 equations and 3 unknowns, can I go about solving them? Very easily. Your calculator can do that. You can use matrix. You can do hand calculations, back substitution, so many ways. From this point onwards, your job is done. The rest is simple math. We have 3 linear equations with 3 unknowns, and this is what your answer is going to be. Clear? Now let's say my direction for I naught was wrong. My assumption along the way was incorrect. Worst case scenario, what would have happened? I would have ended up with a negative sign in the final answer. And what that would have meant is that I simply need to flip the direction of I naught. Make sense? That's it. So if your assumptions are incorrect and I invite you to flip all the current directions or few current directions, right? I can guarantee you that the worst case scenario will be that you will end up with a negative sign for your current. Then you have to bring about your knowledge and competency to use, recognize that this negative sign is not a big deal. All it means is that my direction or assumption for I naught was opposite. So I just need to flip the sign. Does that make sense? Now, what happens if your voltage has a negative sign? Does that mean that you have to make any adjustment? No. A negative voltage does not mean any manual interference or adjustment. Does it make sense? Only the current. If current has a negative sign, you flip the direction. If voltage has a negative sign, you leave it as it is. Now, as you can see, by going through this example, there were so many in between the line understanding, conceptual tests or curveballs that you had to tackle. And that's why students lose points on circuits despite thinking that I've done something similar to this, I should be able to solve it. And chances are that A, B, C, D, the options that you're given, it's very easy to create option number C for a particular mistake, option number D for an incorrect assumption that you're not able to handle, option number B for an incorrect route or direction that you take. So even if you are able to select something from the given options, there's no guarantee that you ended up with the right answer. I hope you found this review helpful. If you're planning to take FE Electrical and Computer exam and want to streamline your exam preparation efforts, I would recommend you to check out my website, studyforfe.com, for a comprehensive step-by-step exam preparation program. Thanks for your time and good luck with your exam preparation.